So in this episode, I'm going to design, build, and install the supports for the shelf, and the close pole for the front entry. Our house is a craftsman-style house, and so I want to have the same feel for the support for a shelf here. I also want to have a close rod that goes across. I think we'll probably put another shelf higher up later on, but in this episode I'm just going to focus on the first part. Now, as I mentioned in the last episode, I am new to woodworking, and I figured with the CNC router I could make things a lot easier. So the goal here is to see how true that is. I'm going to start with designing this in CAD, and then I realized after thinking about it, I was originally going to use just regular wood, solid wood, 1x5s, but then I realized I could use plywood. So I'm going to use 3/4 inch plywood, and you'll see why in a minute when we get to the design. And then I'm going to cut that out in the router, paint it, and install it, and see how it turns out. This is the design that I came up with. I modeled the walls so that I could get an idea of how it would fit. I'm not modeling the outside that has the doors, etc. So let me hide the walls so we can see this a little bit better. And I have it set with display component colors so that I can see the different parts fairly easily that I'm going to be cutting out. As it turns out, these two, by the way, are not exactly the same length because the walls are not square. That's one of the things that I had to learn when I was working on this project, that not all the walls are square. So the back piece is the part where the router came in handy because, as you can see here, I want to have this bracket to support the closed pole. The closed pole has to span a distance of, let's see if I take a look here, about 67 inches. And that's too long really for a pole of this diameter. So it really does need some support in the center, which is why I have this here. So this is a bracket that I purchased and then measured it and recreated it so that I could get the holes in the right position. And you can see that I modeled the holes in here as well. That way I can CNC drill the holes and have everything line up. So the idea of using the CNC machine is that it would make this really easy to do. And I also decided I'd cut this out on the top. At least that was the plan. As I'll explain later, that wasn't the best plan. Anyway, this is a pretty simple design, and the next thing that I needed to do is to lay it out so that I could cut it out on the router. For that, what I did is I created a separate file, and I'll show you the process that I went through. And I imported the parts from the other file. So the first thing I did is actually created a piece of plywood so that I could see how these would fit into the piece of plywood. I started with the back piece and then added the two side pieces. As you can see there, I'll hide the plywood now. And then the top board. And then I added this piece back again, as you'll see here, so that I could do, and positioned it so that I could do some testing. I actually, this is not the final thing, but what I did is I did a test version, which I'll show you on the screen now, to make sure I had the holes in the right position for the bracket before cutting out the rest. To cut them out, it's fairly straightforward. With Fusion 360, I'll go ahead to the setup that I used, which is this one right here. And the first thing is just a 2D contour. I was using a compression cutter. So if we take a look at the settings, I needed to select each of the boards, as you can see there. And then I used a spindle speed of 14,000 RPM and a cutting feed of 90 inches per minute. And then for the depth of cut, I used a maximum step down of 0.15 inches. And that's because the cutter I was using is a compression cutter that has a section at the tip that's 0.13 long. So I needed to get below that section for the top so that it would be pushing down on the top and pulling on the bottom. This did multiple passes. And then the other thing that I did, let's see which one is it on, is I added tabs right here. And if you can see right there is an example of the tabs. So the idea is the tabs would hold it in place and help to keep things from shifting. We can see that better if I go here and regenerate the toolpath. It'll show the stock, and then you can see where it's leaving tabs and also where it has a web that it's not cutting in between the parts. And that web will help provide some stability to keep the parts from shifting. The way I set that up is I have as you can see here, the stock set to be the thickness of the material, which I measured at 0.7 inches, and about a 4 by 8 foot sheet of plywood, as you can see there. Okay, the other thing that I did is you can see that there are these holes in here, and there are also these two holes in there. These are different diameters, so I had to do them in 2 different passes. And one of the things that I like to do is to add comments in here. So this says that these are a 0.08 inch diameter drill, and that I need to use a 2 to 3 millimeter collet. And then this comment tells me it's a 4.65 millimeter drill, which is 0.183. And I don't remember what size collet I used for that, but I did have to switch collets. So I used a chip breaker cycle. As you can see here, it's running at a little over 7,000 RPM, plunging at 50 inches per minute. And then if we look at the cycle, it's doing a chip breaker with partial retract. My thinking there, and I don't know if this is really required, is to make sure that the chips did not build up in the flutes of the drill. So I wanted to retract so it could clear out and then keep going down. I'm not doing production, so I'm happy being conservative about how I do these and perhaps taking longer to perform the operations than required, because I'm just building things for my house and not for other people. 90 inches per minute, as you can see here, is really not that fast, so it does take a while to cut out all of these parts. I've now sped up the video so it'll go by faster and you can see more of the different things that it's doing. It finished cutting the main board, in other words the top board, and now it's cutting the back board that has the little jog in it for the support that's going to hold up the clothes rod. Here it's cutting the first of the 2 sideboards, and now it's working on cutting out the second of the 2 sideboards. I need to swap out the 1/4 inch bit that I used to cut out all the parts and replace it with a drill. To do that, first thing I have to do is disconnect the router and then pull it out, as you can see here. Once I've done that, I can press down on the red button there, and then I can use the wrench to loosen the collet and remove the end mill. Now, at the time that I was shooting this video, I only had 1 nut, and I subsequently decided to buy more nuts because it takes a lot of time to remove the collet from the collet nut and then replace it with a different collet. So I decided to have 1 nut dedicated to each of the different collet sizes I want to use, and that now makes it much faster to swap out the tools from one size to another just by choosing the correct nut that has the right collet in it. Once I've done that, I can then put the drill in and tighten it with the wrench, as you can see here, and reverse the process of putting it back in. It needs to go down straight, as you see here, and then rotate slightly so that the power button is in line with one of the columns, so that the cooling from the fan that is down in the Z unit is lined up correctly so it can do the best job of cooling the router while the router is running. Since I changed the tool that is in the router, I need to set the Z height again. There's this metal plate that you can see here. I'm first cleaning out the area underneath there, and then I'm putting the metal plate in. And then what I need to do is to move the router bit down so it's close to the plate, which I'm doing manually. Once it's fairly close, and then I can press the button which will do the automatic tool height setting. So I've done that, it's moving down slowly, and when it gets down to the right height, it turns green as you saw there, and now the Z is set on the tool. Then I just need to pull the tool setter out and put it back in the slot. And put back this guard, which also has some fins on it, so it helps with the airflow to pull the dust out with the dust extractor. The dust extractor actually does a pretty good job of keeping the dust out of the environment and away from the machine. So then I just need to make some room, make sure it doesn't run into anything, and then I can start drilling the holes, which it is doing here. It's going up and down because of the chip drilling cycle, so it goes in a little bit and then pulls out all the way to make sure that the chips can fly away, and then it goes back in and drills a little bit deeper. It's a little bit slow, but as I say, it's conservative and it gives me confidence that I'm not going to be breaking these drill bits, and this drill bit, as you saw, is pretty small. And then the same process again to pull it out so that I can change from the smaller drill to the slightly less than 5mm drill that I'm going to use to drill the holes for the pins that are on the bracket that will be used to support both ends of the close rod. Because this is a larger drill, you probably heard it make a wah 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 sound, and that's the sound it was making because it was doing the peck drilling. It's now drilling the second hole, and then it can move to the other sideboard and drill the 2 holes there. The tabs that I use to hold these boards in place are not that thick, so I can just use this utility knife to slice through the tabs. Now, one of the things you may notice is that the sideboard is rocking a little bit. I was experiencing problems with this particular plywood with it warping, which is one of the reasons I ended up not using the top board. The cutter, of course, did not leave perfectly square edges here, so I used a chisel to remove the radius that was left behind by the cutter. And this is the first time I've ever done this type of thing, and it was pretty easy, and the results are something I was very happy with. And then it was time for the edge banding. I cut this piece. One end is a little bit more square than the other, so I turned this around so that it was a better fit down in the 90-degree section. And then I just used an iron, as usual, to apply the edge banding. It took a little bit of practice for me to get an idea of how long to keep the iron on there and how quickly to move it along, etc. I have a friend who has done a lot of woodworking, and he said that using a block like this helps hold it in place while the glue cools down. I used a pair of scissors with one of the blades flat against the top so that I could cut it fairly close to flush, as you can see here, and then trim the edges with one of the standard tools that are designed for trimming the edges of the banding. This, of course, does not go all the way down because it's going to hit the other part of this board. So I came back with a chisel to remove the parts that I couldn't remove with a double-sided tool, and this worked just fine. And then a quick sand with a sanding block to smooth off the edges and remove anything that I didn't get with the other 2 methods. I used the same paint that our contractor used for all of the trim inside the house, so this would match the rest of the trim. And I tried a number of different methods. Here I'm using a roller, and this worked, but I had to apply quite a few coats. I then discovered later on that it was much faster to use a brush to apply quite a bit of paint first and then come back later with the roller and to smooth it out. But this enamel, which is a Benjamin Moore enamel, is a self-leveling paint, so it actually turned out really well. Not quite as good as the contractor did, perhaps, but close enough so that unless you look really hard, you're not going to notice the difference, so I was pretty happy with the results. The backboard is held in place by 1 screw and level, so I'm drilling and countersinking the hole for the next screw. I'm using 3-inch long wood screws so that it will go all the way into the stud and hold it firmly in place. And I want to have 2 screws per stud. Because the center support for the bracket is a little bit longer, I decided to add 3 screws here. And I figured that wouldn't hurt. I'm going to be covering them up with putty anyway. And the bracket, of course, is going to be holding up the clothes, or helping to hold up the clothes. So I figured there's no reason not to have 3 in here. And then just driving the screws into them like before. And because they're 3 inches long, they certainly take a bit of work to drive in. Now you can see there that the bit got stuck because I was using the wrong bit. I later purchased the right bit for these. The drilling left a little bit of fuzz, so here I am just sanding it off around the screw holes before filling the holes with wood putty. The sideboards presented a little bit of a challenge because there were no studs on the right side for this one, and then on the other side no studs on the left side. So here I'm drilling holes and countersinking them, and then what I'm going to do with the holes is to enlarge them for the correct size for the anchors that I'm going to be using. And then I put the anchors in and pound them in place with a hammer. These particular anchors have tabs that keep them from rotating, and they're very nice anchors. I'm using my hands to screw in these screws so that I ensure that they go into the anchor and not into the wall. So I'm screwing them in a little bit deeper than the board so I can see by looking behind and make sure that they go into the anchor. And now that I know that they are going into the anchors and not into the wall, I can use the electric screwdriver to screw them in most of the way. I don't want to screw them in all the way because, as you can see on the left, the board is sagging a little bit and I need to line it up, which I'll do next. I want to tighten these by hand so I can feel how tight they are and not over tighten them. So I'm doing first the bottom and the top while holding the board in place. And once they're tight enough, as you'll see, the board stays in place. And then find the stud and mark it. Drill the 2 holes and add the screws. The corner did not have a stud directly behind it, so I needed to drill holes at a 45-degree angle. And then put these screws into these holes also at a 45-degree angle. And that was able to pull it in place and secure it. I did not video filling in the holes and sanding them. What I'm doing here is adding the first of 2 coats that will finish this up. So I'm using the technique that I described earlier, where I'm applying quite a bit of paint with a paintbrush, and then coming back with a roller to even out the coat to make sure that when it dries, it'll come out nice and smooth. I can now start installing the bracket that will hold up the clothes rod. The first screw, which goes at the top, I can screw in most of the way because the bracket has an oval slot, so we can just put the bracket on top of this screw, as you see here. And then once it's sitting there, we can add the second screw to the bottom. Tighten that screw all the way. And then go back up to the top screw and tighten that. A little bit of paint got in the holes that are going to be used to hold up the side brackets, so I just need to chase those with a drill and remove the paint from the holes. I sized the holes so that they would be a slight press fit, and therefore I need to use a mallet to lightly whack them into place. And then the other part just lightly drops into place. To span the closet, I needed to buy 2 pieces of 40-inch long clothes rod, and that means I need to cut them to length. Fortunately, that's pretty easy to do with the bandsaw. Now you may notice that there are actually two pieces here. There's the aluminum piece, and then there's a rubber piece which is under my left index finger. But the bandsaw has no problem cutting into both of them. It's finally finished after, I think, about a month of work. Now, a lot of that was learning how to do things such as painting, waiting for tools and supplies, etc., such as waiting for the anchors that I used to mount the boards to the wall where there wasn't a stud, etc. But I'm really happy with the results, and I'm looking forward to working on more and more complicated projects to get to the point where I can finish the pantry and the storage for the closets in the house. I hope you enjoyed this episode. Please help me grow the channel by commenting below, giving me a thumbs up, and subscribing. And if you're already subscribed, you can click the bell icon next to the subscribe button to be notified when I have another episode. Thanks for watching, and I'll see you next time.